Hello and welcome back to the Anagame series of videos. In this video, we will take a look at the TAP library. This library basically wraps the objects offered by TrekLib, video graphics, and Anaphase into an application structure. This is the library that more or less transforms Anagame from merely a series of libraries into an actual application framework. There are four major objects an application needs to create for it to be considered an Anagame application and use the Anagame framework. A T instance represents a running Anagame application, such as the Anagame builder, and should be created in WinMain, or any non-Windows API equivalent of WinMain, usually called main. The T instance is responsible for creating and holding your main window. Messages sent by Windows and captured by your regular WinProc function should be routed to the T instance as soon as shown on the screen. The T window class is provided to represent your regular window. It holds the drawing board and the T window engine from the video graphics library, so that drawing is possible. It also intercepts messages from the T instance that are meant for this window. Pages represent the view of an application and are responsible for holding a root control, the drawing area available to the page, as well as a handler object to process any events that a control under the page could generate. Pages decide if they are the recipients of a Windows message and send it down to the root control, which then will return with some data indicating what to do. The handler object is responsible for receiving a series of events from the page and calling the appropriate method to run them. It is an abstract class of which you are expected to implement. Here is a graph of setting up the T instance, a regular T window, page, and your custom event handler. The T instance constructor takes in basic information about the main window. Set main window takes in window details, the file to the Anaphase TML, and the event handler instance you constructed. In T window prepare window, the T window calls the show window and update window functions of the Windows API. Compile view will create your page and call set Anaphase. The initialize method in your handler class is meant to be called after your page's set of controls. This is your handler's opportunity to set up track pointers to specific controls and flag the application if the control is either absent or the type of control is not what is expected. In a regular T window, there should only be one page handler pair, and theoretically the window should route a Windows message to that page. When a handler processes an event generated by a control, it does so in the handle events method. For each event, the handler gets the control involved, and from that control gets the series of arguments for that event and a method with the right ID called. With a TIDE window, the process is slightly more complicated. This is because the window attempts to partition drawing space into squares for specific specialized pages called IDE pages. These pages can actually shift each other's borders when the user compels them to. IDE pages work in two layers. The first layer is held specifically by the TIDE window, and they all have access to each other. It's how they are able to move each other's borders. These pages also have a list of page holders which act like tabs. These tabs hold track pointers to the second layer of IDE pages, the one actually holding the content and handlers. One way that these series of handlers and second-level pages are organized are via mini-apps. Below is a diagram showcasing the sequence of how mini-apps are generated. One mini-app type I want to bring attention to is the Arena App 2. The original Arena app was written before the TIDE window and IDE pages. It has a camera page handler and an Arena page handler, with currently no models to draw. The camera handler is capable of sending a message to the Arena handler by way of the T instance. I suppose one day I should add a means to send it through the mini-app as well in a handler message object. This object not only has the message, but data on the handler the message is intended for, so that the T instance can properly identify the handler to receive the message. In the next video, I will go over in greater detail the control messaging system and the means through which an app can save a file in the T IDE window.